Wave nature of particle. In quantum mechanics, a particle of energy E and linear momentum p is represented by a sinusoidal wave of frequency nu and wavelength lambda given in the display, where h is Planck's constant. The wave nature of particles presents new features in particles' motion. A particle's wave function is a solution of a wave equation, known as the Schrödinger equation. It replaces Newton's dynamic equation in classical mechanics. A solution of the wave equation is constrained to be bounded, smooth, and continuous everywhere in space. The display presents a step potential of height u. A particle of energy E greater than u falls from the left on the potential step. Classically, the particle proceeds forward into the high potential region. Only that its velocity reduces in the second region. The red and blue waves are incident and reflected particles waves, respectively. The yellow wave is the total wave throughout the space. The total wave is constrained to be smooth and continuous at the potential interface. The conditions determine the relative amplitude of the reflected wave from the potential interface. Correspondingly, there is a partial reflection of the particle from the potential interface. The particle reflection is a probabilistic event. The reflection probability is the square of the reflected wave amplitude, A prime, to the incident wave amplitude, A, ratio. With E less than U, the incident wave penetrates partially into the potential barrier. That results in a partial penetration of the associated particle into potential region inaccessible by the particle in classical mechanics. The display depicts next the case of E less than U, and where the potential barrier is narrow enough. The wave function is again constrained to be smooth and continuous at the potential interfaces. That determines the relative amplitudes of the reflected and transmitted wave to the other side of the barrier. There is then a chance that the particle penetrates to the other side of the potential barrier, which is impossible in classical mechanics. The penetration is a probabilistic event. The penetration probability is the square of the transmitted wave amplitude to the incident wave amplitude ratio. Visit the website www.cyberphysics.academy for a full view of the tutorial. Send comments to email contact@cyberphysics.academy.